So it tells you exactly what a sequence is at the top, but essentially it's just a list of numbers. And like I said, there's going to be some rule that defines it, so that's just how you'll get all your terms. So we're going to go find these terms. So the thing that you kind of have to remember is that n is the term number, not necessarily the previous term. I think a lot of times we think about like, oh, the pattern is that you add 3, so you have to have the term before to get there. Does that make sense? So do I kind of get what I'm saying with that or no? So like if your pattern was 1, 3, 5, 7, what are they doing each time? They're adding 2, right? So we would think, oh, our rule is plus 2. But that's not necessarily the case, because for these, it's like n is your first term, so technically n would be 1, n would be 2, n would be 3, n would be 4. So you have to come up with a different rule based on the term number, not the previous term. Does that make sense? Okay. If you base it off of like the previous term, that's a recursive function, which is not what we're doing. Questions? Cool. So we're going to find the first 6 terms here. So your rule is right there. So again, that n is the term number. So if you're trying to find the first term, that's going to be a sub 1. So everywhere there's an n, what are we going to plug in? A 1, right? Because instead of a sub n, we have a sub 1, right? So you're going to have 1 minus 1 over 1. Is that okay? So 1 minus 1 gives you what? 0. And 0 over 1 is? 0. So your first term is 0. Is that okay? All right, let's find the second term. What are we plugging in this time? 2. So you're going to have 2 minus 1 over 2. I'm just following that rule that they've got written up here. So 2 minus 1 is what? And 1 over 2? 1/2. Is that okay? All right, so let's find the third term. So we're going to find a sub 3. So we're going to do 3 minus 1 over 3. And what is 3 minus 1? So we've got 2 over 3. Are we kind of seeing how this works? Great. So what's our fourth term going to be? 3/4. What's our fifth term going to be? 4/5. And your sixth term? It'll be 5, 6. Is that okay? Questions? Did I find any of those? Alrighty, so same thing for the next one. We want to find the first 6 terms again, but this time we've got a little bit of a different rule. So if we want to find the first term, we find b sub 1. We're going to have -1 to the 1 plus 1 as our exponent. Then we're going to multiply by 2 divided by 1. Is that okay? We all good plugging in? I hope. So then 1 plus 1 is going to be 2, so -1 squared. What do you get? Positive 1, right? And then 2 over 1 is 2, so we've got positive 1 times 2, which is going to give you 2. Then if we go find the second term, so b sub 2, we're going to have -1 to the 2 plus 1, and then we're going to multiply by 2 divided by 2. So this time we've got -1 to the third, which is going to be negative, and then 2 divided by 2 is 1, so this whole thing is -1. Is that okay? Alright, so your third term, b sub 3, we're going to have -1 to the 3 plus 1, and then we're going to multiply by 2 divided by 3. So we're going to have -1 to the fourth, which is what? Positive 1 times 2/3, so our answer is just 2/3. So are we noticing a pattern with the -1? 2/3. So the -1 out front is just flip-flopping your answer to negative and positive, right? So that's where that's coming from. So your fourth term, I have one over here, we'll try it. So we've got -1 to the 4 plus 1. So is our answer going to be positive or negative this time? Negative. And then we've got 2 over 4. So 2 over 4 is going to reduce to 1/2. And we said this is going to give us a negative. So your answer is -1/2. Is that all right? Okay. So your fifth term, is it going to be positive or negative? And it's going to end up being positive. We've got negative 1 to the 5 plus 1 times 2 over 5. So we've got 2/5, and we said it would be positive, so positive 2/5. And then for our last term, we've got b sub 6. Is it going to be positive or negative? It's going to be negative, and then we have 2 over 6. And what does that reduce to? 1/3, so it's going to be negative 1/3. Questions? Alrighty. So for the next one, we're finding your first 6 terms. Again, your rule is a little bit different this time. It's going to be n. If it's even, it's going to be 1 over n if it's odd. So if we're finding our first term, c sub 1, is that even or odd? Odd, so it's going to be 1 over 1, which is just 1. Is that okay? So then if we want to find c sub 2, our second term, is 2 even or odd? Even, so it's just going to be 2. And what about your third term? Even or odd? Odd, so it's going to be 1 over 3. Is that okay? What's your fourth term going to be? Even, so just 4. And your fifth term? 1 over 5, because it's odd. And your last term? Just 6, because it's even. Questions? Pretty easy, right? Okay, cool. So the next section, we're given the sequence, and we need to find the pattern. So again, it's based on the term number, not necessarily like what they're doing each time. So we're going to number each one, and then I think it's going to be a little bit easier to see the pattern. So this is your first term, your second term, your third term, your fourth term. So what do you think they're doing? Or what does it look like the rule might be? E to the n over n, right? Do we kind of see that? So we'll say a sub n equals e to the n over n. Is that okay? Questions? All right, so for the next one, we've got our first term, our second term, our third term, our fourth term. So this is a little bit trickier. What do we think? Do you have any ideas? Well, I'll tell you, I was thinking like 3 squared, right? So 3 to some exponent, because we've got 3, so like 3 to the first, 3 to the second, 3 cubed. That's 3, 9, 27, right? But if it's our second term, we can't just say 3 to the n, right? So how could we change that so that's what we need? So we know that like 3 to the first gives you 3, right? So what do we have to do to n to get to 1? So we have to do what? What do you have to do to n to get to 1? If n is 2, there we go. So it's 1 over 3 to the n minus 1. Is that okay? Questions? Okay, cool. So the next one, we have 1, 3, 5, 7. So again, I'm going to label your terms. So first term, second term, third term, fourth term. So again, it looks like they're just adding 2. But like I said earlier, we can't just say plus 2 as our rule. So we've got to figure out what they're doing as far as the term number is concerned. So like, I think it's easier to start on the second or third term, because if you look at the first one, a lot of times you can't really tell what's going on because it's just 1. But what would you have to do to 2 to get 3? If we do plus 1, so then does 3 plus 1 give us 5? No, so that rule's not going to work. Let's try something else. What else can we do to 2 that would get us to 3? So if we do 2 times 2, you get 4 minus 1 gives you 3. So that checks out. Let's check it with 5, or with the third term. So 3 times 2 gives you 6 minus 1 is 5. That checks out. And then with the 4 times 2 is 8 minus 1. So there's our rule. Is that okay? So we're doing 2 times n minus 1. Questions? Alrighty, so the next one we got 1, 4, 9, 16, 25. I think this is the easiest one. What do you think our pattern is? It's just squared, so we would just write what? N squared, awesome. Not hard, right? So for E, this one's kind of got two parts going on that we've got to look at. So we've got our first term, second term, third term, fourth term, fifth term. So what do you notice is flip-flopping or going back and forth? The negative, right? What's up? Do you have a question? What do you mean? That's just not how they work. It's just not how it works. Because it's based on the term number. I don't know why, it just is. What's that? I'm sorry? Probably. I mean, you could make a more complicated formula. I'm sure they could get you there. But I would just try to find the easiest one. Any other questions before we get back to E? Alright, so for E, what do you notice is flip-flopping each time? The negative. So we had one that did that before, right? So up here, we flip-flop between negatives as well. So we're going to use that chunk again. So you got that -1 to the n plus 1. And that's going to work because we were positive, negative, positive, negative. So that's going to get us what we need there. So -1 to the n plus 1. Now, if it started negative instead of starting positive, how would we change this? Just n. Does that make sense? Because if it's into the first and it's the -1, it's going to keep that negative sign. Does that make sense? Okay. And if you did -1, then it would still go like switch. So what's next? Oh, how are we getting the 1 over whatever? Just 1 over n. Is that okay? Questions? Okay, cool. So at the bottom here, we're talking about factorials. Have y'all ever seen these before?
Yes.
Yeah, in statistics, right? If you've taken statistics, that's where they pop up a lot. Yes. So you can do these in your calculator, but basically just what it means. So like if you're doing 9 factorial, that means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So you go from that number all the way down to 1. Does that make sense? Which is a lot to type out, which is a lot to do. So your calculator does that for you. So on your calculator, you're going to type 9. And then you're going to go to menu. And then where have y'all seen this sign before? And statistics. Actually, it's actually under probability. Sorry. It's under probability, and it's your first option there. Factorial. Is that a shortcut? Y'all, there's a shortcut beside a G. The little question mark button on the bottom. I knew there was going to be one somewhere, but I wasn't sure where it was. Anywho, beside a G on the bottom, that question mark, if you hit that, that's your shortcut. But anywho, just hit enter, and it gives you 9 factorial. That's your answer there. Is that okay? So we can just write that down. 362,880. I mean, that's just one step in the whole thing. Alright, so the next one we got 12 factorial over 10 factorial, so I'm going to go ahead and get my little fraction set up. We got 12, I'm going to use that shortcut, over 10. That okay? These are literally just typing in the calculator. Are we alright with that? Kind of tricky, be careful. So we got 132 there, is that okay? Questions? Okay, so find the last one. Be sure that when you're typing that one in, that you put a times in between the 3 and the 7. Sometimes your calculator gets confused, and if you just write stuff straight like we would without the multiplication in between, it doesn't quite know what you mean. So just make sure you put that times in between there. It might do fine without it, but sometimes it doesn't. So err on the side of caution. Did we get an answer there? 1260. Questions on factorials? We all right? Okay, cool. Moving on. So what we did before, all of those sequences were defined by the term number. What we're doing now are recursive functions, so they're defined by the term before, so the previous term. So like we were saying with this term, or with this sequence, then you could just say plus 2, and that's fine, because it would be like a sub n equals a sub n minus 1 plus 2. So you take the term before and add 2. That's your rule. Does that make any sense? So recursive functions use the one before to get you there. So we're going to do this one. We're going to find the first 5 terms of this recursive sequence. So we've got u sub 1 equals 1, u sub 2 equals 1. So then to find your next term, you're going to do u sub n equals u sub n minus 2 plus u sub n minus 1. So you're adding the previous 2 terms to get the next one. Yeah? Does that make any sense? Okay. So I think that it's helpful to like write them all out so that you've got them to like reference back to. If you want to do that, awesome. If you don't, that's okay too. So we've got u sub 1 is 1, u sub 2 is also 1. We want to find u sub 3. If we do 3 minus 2, what do you get? 1. So u sub 1 plus 3 minus 1 gives you what? 3 minus 1, 2. So u sub 2 there. Does that make sense? So you're taking whatever your n is. We're using this rule right here. So n minus 2. 3 minus 2 gave us 1. N minus 1. 3 minus 1 gave us 2. Is that okay? So what was u sub 1? 1. What was u sub 2? Also 1. Add those together. What do you get? 2. So u sub 3 is 2. Is that okay? Questions on where that came from? All right, so let's find the fourth one. So we've got u sub 4. So what is 4 minus 2? So that's going to be u sub 2 plus 4 minus 1, 3. Is that okay? So what was u sub 2? 1. And u sub 3? 2. So 1 plus 2 gives you 3. So your fourth term is 3. Is that okay? So it only lets us to find 5, so we'll find our next one and we'll be done. So u sub 5. So if we plug a 5 in for n, what is 5 minus 2? 3. And then we need to do 5 minus 1. So 4. What was u sub 3? 2. And u sub 4? 3. So 3 plus 2? 5. Is that okay? Questions? All right. So you're going to start using sigma notation to find all these. So your sequence is just all the like numbers listed out. When you add those all together, it's now called a series. So your sigma notation is how you find that. So basically just adding all the whole sequence together. So what we're going to do is technically a partial summation because it's not the whole thing, because your sequence could go on forever, right? It's infinite. So we're not going to find all of it yet. So these should technically be like sub numbers, but I didn't fix that, so sorry. And here's how you find that. So again, you basically just add up all the numbers in your sequence. K is your index, and that just tells you where you start, and then the number on top of your sigma is the number you end at, or the term number that you end at, and then inside right here is where you put your rule. Is that okay? All right, so they've got the first one here. It wants us to write out the sum. Are we actually going to find it? We can't actually find it because it's not hard. So you're doing, your rule is 1 over k, and we're going from 1 to 10. So your first term would be like 1 over 1. Does that make sense? Because we're starting at 1. So then you would have plus 1 over 2. Okay, that would be the next one that we got to add. 1 over 3. And you're going all the way to what? 1 over 10. And we would just add all those up. We're going to stop there. We're not going to take that one any further. We'll do that later. Okay, so are we good with writing all that out with real numbers? Yeah? So now we're going to do it from 1 to n. Okay, so it's like your rule is factorial. So the first one's going to be 1 factorial plus, what will come next? 2 factorial. And then what will we have? 3 factorial. And we would keep going till we get to the last one, which is n. So we'll just put plus n factorial. Is that okay? So they may ask you to write out a sum like that, so you've got to know how to use those variables. So typically, if you just do like the first 3 or 4 here, and then do dot, 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 and then write your rule with the variable in it, that'll be enough. Does that make any sense? Questions? Okay, so we want to take these and write it in summation notation now. So you've got to have your big sigma, and we're going to have k equals. Where do you think we're probably starting? A lot of practice. It's kind of like a Z. Yeah, kind of like a sideways in. That's a good way to think of it. So if you need a light, flip your paper, draw it in, and then flip it back. That'd be a lot of work. Anyway, well, what do you think we're starting at? 1. And then where are we ending? 9. What is our rule? K squared. Is that okay? K squared. Questions? All right, so moving on to the next one. We're going to draw that sigma again. And k equals what? Where are we starting? 1. And where are we going? You have a variable in the end, so you're probably just going to n. And so that's your rule, y'all, right? So when we go write it in here, you're just going to replace that n with a k. That's all. So we've got 1 over 2 to the k minus 1. And that's it. Questions? Anything we're not sure about, don't quite understand? Okay, cool. So the next section is telling you about the properties of all this sigma notation stuff. So basically, if you've got a constant inside, you could pull it outside and you'll have the same answer. If you're adding 2 different rules, you could separate them into 2 separate sigma notations and add those together. Same thing if you're subtracting. And then the last one here is just talking about if you're going from k equals j plus 1 to n, you could separate those as well and go from 1 to n and then subtract 1 to j. I don't think you're going to have to do that, so don't worry about it. The bottom section, we want to find the sums. So we've got k equals 1, we're going all the way to 5, and your rule is k squared. So what is our first thing going to be? 1 what? Squared plus what? 2 squared plus 3 squared plus 4 squared plus 5 squared. Is that okay? Are we good with all that? Right, we're just plugging. So you can type that in your calculator. 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. But if you're going from like 1 to 100, that's going to be very tedious, right? So you're going to use the summation notation function on your calculator. So go to menu, and we're going to choose calculus. And then you're going to choose sum. There's also a shortcut for this, and we'll show you that in a second. So now you have like your big sigma, right? So you just type in what we have to start with. So we've got k equals 1, and your rule is k squared, and we're going to 5. And we'll hit enter, and you get your answer done. Is that okay? So again, you don't really have to know how to work all that because your calculator will do it for you. Which is super helpful if you've got to go from like 1 to 100 or something crazy like that. So again, we get 55, which I think is what y'all said you already had, right? Okay. So I do want us to write out what you would do for all of these, just so that we like understand what's happening. But then we're going to find the actual sum from our calculators. So for the next one, we've got 1 over j, and j starts at 3 and goes to 5. So what would our first term be? And our next term? 4. And our last term? 1 over 5. So again, you could just add 1/3 plus 1/4 plus 1/5. That's totally fine. Or you can use that sigma notation again. So I believe it's under the book button. That was a lie. It's not under the book button. It's under the button beside the book button. And then you just found the sigma, and it's right there. Huh? Huh? That okay? So that's your shortcut, or you can just do menu, calculus, and choose sum. And it doesn't matter what variable you use there, as long as you define it the same on the inside and outside. So like they have j's here, you can type in j's, you can type in x's, you can type in k's, it doesn't matter, as long as they're the same. So what do you end up getting there? 47 over 60. Questions? Okay, cool. So moving on to number 7. Our rule is just I, so it's just your variable, and we're going from 5 to 10. So what's our first term going to be? 5 plus 6 all the way to 10. And when you type that in your calculator, when you add them all up, what do you get? 45. Questions? Are we going too fast on these? I feel like y'all have already done them, basically. Okay, cool. The last one is a little bit weird, because your rule is just 2. So what's our first number going to be? 2. Your second number? Still 2. And we're going how many times? 6. So you can just say 2 times 6, and you get the same answer. But we're writing 2 out 6 times, because you're going from 1 to 6 to 2 plus 2 plus 3, 4, 5, 6. And we get 12 there. Is that okay? Questions? Anything we're not quite sure about, don't understand? Wonderful. Well, let me give you a breakfast.